Okay, so Pythagorean Theorem, hopefully this is something you've heard before. A squared plus b squared equals c squared. And you can use that when you have a right triangle and you have a missing piece of a right triangle. You have to know that the hypotenuse is always opposite the 90-degree angle. Hypotenuse is the longest side of the triangle at C. It always has to be the letter C also. The A and B don't really matter which one you call A and which one you call B. It's just the legs that make the 90 degrees. Those are the legs of the triangle. And C, the hypotenuse, always has to be the long side. Alright, so we're going to use that. Alright, so the actual theorem is in a right triangle, the sum of the what? This. Is that supposed to? That's not what that's supposed to say. The sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So that should say squares, not squats. Squares makes more sense. The sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So a squared plus b squared equals c squared. So first we're going to practice squaring a number and a square root. So if there's a radical and you need to square it, then you take the whole thing and you put it in parentheses, squared. So if, say, A, what the length of the side of the triangle was 3 times the square root of 5, and you want to use the Pythagorean theorem, you have to square it. So you put the whole thing in parentheses, and it's really, you just square both pieces. You're going to square the 3, and you're going to square the square root of 5. So this is 3 squared times the square root of 5 squared. And as we went over on Tuesday, if you can cancel a radical by squaring it. So those just go away. Now it's 9 times 5, so it's 45. And again, for the next one, the same thing. We're going to square the entire value. So we put in parentheses squared. So we're going to square both pieces, square the 5 and square the square root of 3. So it's 5 squared times the square root of 3 squared. Anytime you have a radical squared, they cancel each other out. So this is 25 times 3, so it is 75. Alright, so that's just a quick recap on how to square a radical, or a value with a radical. Alright, using the Pythagorean theorem, we're going to find the unknown lengths of each right triangle and leave the answers in simplified radical form. So not in decimals. We're using simplified radical form. That's what we've been practicing for the past few days. Alright, so we have an A, we have a B, and we are told, it's very important, that these are right triangles. If these are just two values and we want the third value, we can't use the Pythagorean theorem. That is only for right triangles. So we're told this is two sides of a right triangle. That's the legs of the right triangle, A and B. Find the other one and leave it in simplest radical form. So we have, actually I'm going to write it out, a squared plus b squared equals c squared. And we know that a is 12, so it's 12 squared plus b squared, and we know that b is 9, so plus 9 squared equals c squared. So we can figure this out. We can actually just type everything on the left in the calculator, 12 squared plus 9 squared, and it will do it for you. But I'm going to go ahead and Write it out. This will be 144 plus 81 equals c squared. 144 plus 81 is 225. So 225 equals c squared. But we were asked to find c. So to get c by itself, we want to take the square root. Take the square root of c squared, and then you have to do the same thing to both sides. So c squared becomes just c. And the square root of 225 is 15. So c equals 15. So this is when you're given two of the values and you're told it's a right triangle and you can find the third. You plug it in the formula like this. And you have to pay attention to which letters you're given. Because on number 1, I was given A and B, told to find C. On number 2, I'm given A and I'm given C and asked to find B. So it's not, you have to make sure you get it in the correct order. So again, I'm going to write the formula. A squared plus B squared equals C squared. And this time make sure that either your C goes in the right spot. So A is 3, so 3 squared. I don't know what B squared is. And that equals C squared, and C is 2 times the square root of 3. So that whole thing is squared. Okay, so now I need to solve for B. So I'm going to square my values. 3 squared is 9 plus B squared equals 2 square root of 3 squared. So I'm going to square the 2, and that's a 4. If I square the square root of 3, square root squared cancels, so that's just 3. So 4 times 3. And I know 4 times 3 is 12. So 9 plus B squared equals 12. Since I'm trying to get B by itself, I'm going to subtract 9. Let me take it up here. Oh. So B squared equals 3. But I don't want B squared, I want just B. So to get rid of the radical, I'm going to take the square root. Square root squared cancel. So B equals the square root of 3. And since I can't simplify that any further, that is it. B equals the square root of 3. So that's when you're just given the values. Again, make sure that you get them in the correct place. You have to make sure you line them up right. Number 3, I'm given a picture, and I can tell that it is a right triangle because it has that little box in the corner. So again, you have to use Pythagorean Theorem, it has to be a right triangle. And I want to find out what the value of y is. Y is a leg because it forms the 90-degree angle with the side that has a length of 6. So I can set this up as y squared plus 6 squared equals 10 squared. So the longest side is always the hypotenuse, which is always c. And you can tell because it's going to be across from 90 degrees. That is c. Every time. The a and the b, I could have written 6 squared plus y squared equals 10 squared, and it wouldn't matter. And then I'm solving. So y squared plus 36 equals 100. And then I can subtract 36. So y squared equals 64. And then the last step is to get y by itself, because it's y squared, but I don't want y squared. I want to take the square root of that. So square root squared cancel. So y equals the square root of 64, and 64 is a perfect square. So that means it's 8. So y equals 8. Okay. The next one is a word problem. We have a roofer leans a 16-foot ladder against a house. Okay, so you can kind of imagine what that's looking like. The base of the ladder is 5 feet from the house. How high up the house does the ladder reach? You really, really, really need to draw a picture when you do these problems. And we're going to have a lot of this kind of thing. So first, it doesn't have to be a very detailed picture. It could be just a triangle. You know it's going to be a triangle because we are in a section about special triangles. But if not, then just say this is a house. So you have like, I don't know, we'll make this a brick wall, right? Brick wall, however you want to draw it. Mine's pretty bad. It's fine. So that's my house. Okay. And then I have the ground, obviously. There's the ground. Yeah. And there's a ladder. The roofer leans a 16-foot ladder against a house. All right, so there's my ladder. You can draw as detailed as you want. It doesn't matter. And I know that's 16 feet long. The ladder is 16 foot. If the base of the ladder is 5 feet from the house, okay, so down here is 5, because it's 5 feet from the house, how high up the house does the ladder reach? So that's what we're looking for. And you can see, and so we're assuming that this is a straight house, so that should be a 90-degree angle between the house and the ground. We're assuming flat ground and a vertical wall. So if I were to redraw that as just a triangle, which your drawing could have been this simple, where you know that the house is on the left and that's X, that's what I'm looking for, and 5 is on the bottom and 16 is the ladder. So you could do either type of drawing, it doesn't matter, whatever works for you, or something in between. And now I have a right triangle with a missing side, so I can set this up using Pythagorean Theorem. A squared plus b squared equals c squared. And I know that C is always across from 90 degrees. So 16 is C. I have a side that is 5. So I'll just make that B. And I don't know what a squared is. So I could either plug in an x or I could leave it as a. It doesn't matter, whichever one you're more comfortable with. So I'm going to make it x. It's the height up the wall that the ladder reaches is x squared. And then from there I'm just going to solve it. So I have x squared. You could either square the 5 and square the 16, or you could just say minus 5 squared and do 6, and then on the other, I'm just going to do that instead of describing it. We could just say minus 5 squared, like that, and then 5 squared minus 5 squared cancels. So x equals 16 squared minus 5 squared, and you could type that in the calculator, or you can calculate them out, which was 16. I have that over there. I don't. So 256. So x squared equals 256 minus 25. Which is 231. X squared equals 231. We're going to leave our answers in simplest radical form. I don't know what the height is. I don't know x yet. I just have x squared. So I do need to take the square root of both sides. So now I have x equals the square root of 231. Calculator. There it is. And so now I need to simplify the radical. So remember, if you have your list of perfect squares, we have 4, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, that's probably plenty. And so now I want to see what value, what's the largest value on that list that 231 is divisible by to get a whole number. So 231, what if I divide it by 121? No. Nope. 81? Nope. 231 divided by 64? Nope. 49. 36. Nope. 16. It does not divide by anything. So add 15. Alright, so it doesn't divide by any of these numbers. So that means we just leave it as the square root of 231, even though that's very large. It doesn't make sense. That's square root of 231. So what is the square root of 231? $15. That does make sense. So if we always like to check my word problems to see if it makes sense. So square root of 231 is roughly 15.2. So then I go back to my problem and I think about this. If I have a 16-foot ladder that's 5 feet away from a house, can it reach 15.2 feet up the wall? That makes sense. It's a little shorter than the ladder. If I got like 17.2, that would not make sense, right? Because that was higher than the ladder could reach even if it was standing straight up. The ladder's not that long. But if it's shorter, then if I had the ladder and I pull it out from the bottom, that makes sense. It's almost 16 foot, but not quite. So yes, it makes sense. So that's my answer. All right, so that is Pythagorean Theorem and how to use it. So on the back, there's a little bit more. We have Pythagorean triples. Pythagorean triples are special sets of numbers that if you recognize, you know that they will make a right triangle. So basically, if you recognize these values, if you're given a right triangle and it has side lengths of 3 and 4, then you know the hypotenuse is going to be a 5. If you have the same with the next one. If you're given A and B are 12, then you know the hypotenuse is 13. Or if you're given the hypotenuse is 17 and one side is 15, you know the other side has to be 8. So these are just Pythagorean triples that are commonly used. And if you recognize those numbers, it just saves you work. It's not something you have to memorize. You can still solve for these just the same as you would solve for everything, but they're just some common known Pythagorean triples. All right, so determine if the set of side lengths given forms a Pythagorean triple. So do these work? Are they multiples? So if they work, that means they satisfy the Pythagorean theorem. It gives you a true statement. So that's this type of problem, is when you're asked to determine, you're just applying the Pythagorean theorem and seeing if it's true or false. So that's basically a true-false question. So we have 20, 21, 29. You do have to make sure you get the longest piece to be C. That has to be C. So 20 squared plus 21 squared, does that equal 29 squared? That's the question. So you can just type it in as 20 squared plus 21 squared is 841. So does 841 equal 29 squared? 29 squared is 841. So yes, it does. This is yes. Because 841 equals 841. Try the next one. 10, 17, 26, so 26 must be C. 10 squared plus 17 squared equal to 26 squared. That's what we're trying to figure out. So we have 10 squared plus 17 squared. Hold on. It's 389. Does 389 equal 26 squared? Which is 676. Well, clearly it does not equal, so this is no. And then the same thing with the last one. 41, 9, 40, so 41 is C. To make sure you find the correct value for C. 9 squared plus 40 squared equal to 41 squared. Nine squared plus 40 squared is 1,681. And 41 squared is 1,681. So yes, those form a right triangle. They are a Pythagorean triple. So Pythagorean triple are three values that can form a right triangle. And every time I give you a theorem, I give you the converse of that theorem. So if you use the theorem to find a missing value, if you have the values, you can compare them. And if a triangle is not a right triangle, then it is either acute or obtuse. I do not like the way those equations are written. I just noticed that. When you do the converse, you should just flip the equation. Because remember, it's going backwards, and I promise it makes you this much easier. What I'm going to write is equivalent, but if you go with C squared is equal to A squared plus B squared, instead of that way, whenever you use the converse, C squared is less than A squared plus B squared, and C squared is greater than A squared plus B squared. Because if you do it the way it's printed on the paper, it gets confusing with the symbols for acute and obtuse, because whenever it's written like this, that looks like the greater than symbol, which would make you think obtuse. But if you flip it around and you start with C, for the converse you start with C, then it's the less than symbol, and the less than symbol should make you think of acute. So make sure whenever you're doing the converse and you're trying to figure out obtuse or acute, right doesn't matter because equal sign's equal sign. But if you're looking for obtuse or acute, make sure you flip it around. Because then your greater than or less than will match obtuse and acute. It makes it a lot easier. So this is, again, a determined situation. Determine whether the triangle is determine whether the triangle, that doesn't make sense. What's it supposed to say? First, determine whether the triangle form. I don't know what that was supposed to say. Whether the triangle is acute, upright, or obtuse. Whatever. We're just deciding what type of triangle this would make. So we're going to set this up as c squared, and then I'm going to do a big circle because that's what I'm filling in. A squared plus b squared. This is for the converse. My options will be equal, greater than, or less than. Greater than is going to be obtuse, less than is going to be acute. So I have the three values. The first thing I need to do is figure out the c. C is always the largest number. So 10 squared blank 6 squared plus 4 squared. 10 squared is 100 blank. We have 36 plus 16. So that's 52. All right, so 100 is greater than 52. So that means I have an obtuse triangle.
Can that one be a triangle? If the two smallest ones are equal to and not greater than the 10.
You're right, that is not a very good example, is it? These notes are not very nice.
Well, because it says determine whether the first...
Oh, that's what it was trying to say. Determine whether the triangle is first forms. First, determine whether the triangle forms a triangle. Right, can it be a triangle? So to be a triangle, 6 plus 4 must be greater than 10. So 10 greater than 10, it is not, so this is not even a triangle. You're right. We can just get rid of all that. Not a triangle. And that's why. Because 6 plus 4 is not greater than 10. Very nice. Next, number 6. 8 square root 2 and 12. Which one's the largest value? If you're not sure, you can multiply 8 times the square root of 2 and look at the decimal. But 12 is the largest number. So, well, I guess we do need to add them together, don't we? So 8 times the square root of 2. 8 square root of 2 is about 11.3. So this is about equal to 11.3. So first, 8 plus 11.3, is it greater than 12? So that would be 19.3 is greater than 12. Yes, so it does form a triangle. Now that we know it forms a triangle, we want to see what type of triangle does it form. So we're going to say 12 squared, because 12 is going to be the c value, blank 8 squared plus 8 square root of 2 squared. And since we're not really worried about solving, you can just type that in your calculator and get a decimal, because the answer here is not a value, so we don't have to keep it in simplest terms. We just want to know, is it greater than or less than? So if we have 8 squared plus 8 times the square root of 2. I didn't put my parentheses. You do need to put parentheses around the 8 and the square root of 2, like the way I wrote it, whenever you put it in your calculator, or it will not do it correctly. So that gives me 192. And 12 squared is 144. 144 is less than 192, so this is going to give me an acute triangle. Okay, so then number 7, our C value would be 36 because that's the largest number. First, let's check, is this a triangle? 24 plus 20 would be 44. Is 44 greater than 36? Yes, so yes, it makes a triangle. So now we can do 36 squared blank 24 squared plus 20 squared. 36 squared is 1296. And then 24 squared plus 20 squared is 976. 1296 is larger than 976. So this will make an obtuse triangle. And if they were equal, it would be like what we did above. Those are right triangles.